Hey, what are you doing?
I'm just finishing this book called Preventing Skin Injuries and Burns.
Do they classify it as non-friction?
Wait, so what did you mean by friction anyways?
Well, there are two types of friction, static friction and kinetic friction. Static friction is a force between two surfaces that prevents those surfaces from sliding past one another. Kinetic friction, on the other hand, describes frictional forces that are sliding past one another. So for example, if you are sitting down on a slide, kinetic force of friction slows you down and reduces the speed at which the forces slide across from one another.
And so these two forces are related by the coefficient of static friction. You can continue to add force to an object and it may not move, and so it's still exhibiting static friction. However, the point at which it just starts to move is when the coefficient of static friction has been surpassed, and now you have kinetic friction. And, fun fact, the coefficient of kinetic friction is always less than that of static friction, as in it takes less energy to move an object once it's in motion. Oh yeah, I remember this now. Hey, I wonder if we can see a practical example of static friction in our lives.
Yeah, for sure. Let's take your Preventing Skin and Injuries book and put this AirPod case on top and see how it holds up. While it's horizontal, there's static friction between the two cancels out and it equals 0.
But if we start to tilt the book, static friction now has to be above 0 to counteract the effects of the tilt.
Exactly, and if we continue to tilt it, it'll eventually get to the point where the coefficient of static friction is exceeded and it allows the AirPods case to slide right off.
Wow, that's so cool. Do you think it's possible to calculate the force of static friction right before the kinetic forces occur?
I don't see why not. Let's calculate it.
Yay!
From our trials, we found the opposite and adjacent lengths. Then we used the tan law to find the angle from each trial. Now we will find the average from these angles, which is 15.14 degrees. We are doing this so we have a more reliable measure of what the angle is. We also found the weight of the AirPods case to be 46 grams or 0.46 kilograms. So now we can go ahead and draw the free body diagram for the AirPods and their case. That way we understand the forces at play. This is recreating the model. And on top I will draw the free body diagram. So we have the force of gravity, we have the normal force, and then we have the force of friction. And just to be clear, I will draw the two components of the force of gravity.
Great, so now we can find the force of friction. So the force of friction, of static friction, is equal to the coefficient of static friction times the normal force. And from our free body diagram, we know that the normal force is equal to the corresponding component of the force of gravity. So the normal force is equal to mass times gravity times cos theta. And now we can plug this equation back in to our force of static friction equation to give us the force of static friction as equaling to the coefficient of static friction times mass, gravity, and cos theta, all multiplied to each other. And now we need to consider the force of gravity that is acting in the component opposite to the force of friction. So that would equal mass times gravity times sine theta. At this point, it's important to note that when the object just begins to slide, the force of gravity is equal to this force of static friction. So we can equate these two equations, and that would give us force of static friction is equal to force of gravity, and plugging in what we know, that would give us the coefficient of static friction times mass times gravity times cos theta is equal to mass times gravity times sine theta. And now isolating for the coefficient of static friction, we get this equation. And we can cancel out mass and gravity, giving us this equation. And plugging in the angle that we found earlier, our theta earlier, we get a coefficient of static friction as equaling to 0.27. Now we can plug this back into our original force of static friction equation to give us the force of static friction. So that would be our coefficient of static friction that we just found times the mass, which is 0.046 kilograms, times gravity, which is 9.8, times cos theta. And that would give us 0.705 newtons. And this is our force of static friction. Wow, that was so cool. Looks like I learned about non-frictional forces and frictional forces all in one day.